Okay, so the first thing for naming this graph is there's an error here on where the axes are put. So we need to put the axes, and this you'll see this in my solutions too. The axes need to be here. I should say, not the axes, the y-axis. So that was an error on where it was put. And then it will make sense when we find our equation of our graph. So there's the y-axis. Of course, we already have the x-axis. And some things we can get right away from the graph are the amplitude and the vertical shift. So the vertical shift, or the new midline, is going to be at 3. So the vertical shift is up 3. And then that would make the amplitude 1. So, and look at there. We have 1 point that is actually going through that, that midline. So, and you've got to decide which equation you want to find first. I think I decided when we did this in class that I was going to do cosine first. So cosine starts, if it has a positive in front of its amplitude, it starts at its high point and goes down. So I'm going to have it starting there, so a little bit to the left of the y-axis. And this would be then, if I think of, that's my new quote 0. So to the right of that would be quadrant 1 angles, then quadrant 2, quadrant 3, quadrant 4, and then going around again, quadrant 1, quadrant 2, quadrant 3. So when I go about finding my function here, I'm going to say y equals cosine bx plus or minus c, it doesn't matter, plus 3. Okay, so let's plug in that point 11 force 3 for x and y, 11 force b plus c plus 3. So we've got this cosine of 11 force b plus c equals 0. All right, so, it's between quadrant 1 and quadrant 2, which makes sense, landing on the midline. If it were here, the point, that would be pi over 2, but it's more than 1 period away from my starting point. So the angle, when I take the cosine that I get 0 there, is going to be 5 pi over 2. So that's going to be my first equation. And now let's plug in the second point. So 2.5 equals cosine of 23rd 6b plus c plus 3. So I'll get negative 1/2 when I subtract 3. And once again, I'm deciding what angle is corresponding to this point. So cosine of what angle gives me negative 1/2. Well, I know the reference angle is pi over 3. So I'm looking at a quadrant 3 angle, but it's more than 1 period away from my starting point. So it's going to be 2 pi. The angle will be 2 pi plus that quadrant 3 angle that gives me negative 1/2, which would be 4 pi over 3. So it's going to be 10 pi over 3. So 23 6b plus c equals 10 pi over 3. And now I'm just going to do my systems of equations. So maybe I'll multiply this by negative 1. And so when I do this, I get negative 11 force b minus c equals negative 5 pi over 2. Oh boy, common denominator. All right, so 12. So I'll do 46 twelfths b minus 33 twelfths b. So that's going to give me 13 twelfths b. So I'm going to get 13 twelfths b. The c's are canceling. So 13 twelfths b, 12ths, there we go, equals, common denominator will be 6. So let's do 20 pi over 6 minus 15 pi over 6. That's going to be 5 pi over 6. So I'm going to get 5 pi over 6. Okay, so then when I go to solve here for b by multiplying by 12, so b, let's just do it, 5 pi over 6 times 12/13, it's going to give me 10 pi over 13. Not actually a lovely b, but all right, so here's what I got. I've got y equals cosine 10 pi over 13b. I've got to find my c value, and then I've got plus 3. Well, I did the hard part, because once I found that b value, I now can use one of the equations and plug it in for c. So maybe I'll use this one. I'll do 23/6. I just found b, 10 pi over 13, plus c equals 10 pi over 3. So if I simplify a little, so this will be 3, 5. So I'm going to get, still not lovely here, I'm going to get 115 pi, and then 39 plus c equals, let's make a common denominator here, so 130 pi over 39. So c is going to be 15 pi over 39, but we can simplify that to 5 pi over 13. Yeah, dividing the top and bottom by 3. Okay, so this is going to be, going back to my equation, 5 pi over 13, which makes sense now because, you know, after there's going to be a shift with that plus there, a shift to the left from what it normally is. So there we go. And now to find the cosine, you don't have to do the systems of equations. To find the sine, you don't have to go back and do systems of equations. You instead could just say, okay, everything's the same except the relationship between sine and cosine is that cofunction relationship. So sine of pi over 2 minus 10 pi over 13. Oh gosh, I put b in there. Sorry there. That should be x. I don't know why it's not erasing. That's not b. That's x. X plus 5 pi over 13 plus 3. And then just doing a little bit of fraction work again. This problem's a little bit of a beast with how much fraction work there is. So it's negative 10 pi over 13x. Pi over 2 minus 5 pi over 13, well, that will be 13 pi over 26 minus 10 pi over 26, which looks like it's going to be 3 pi over 26. So plus 3 pi over 26 plus 3. And then you can't leave your answer with a negative in front of a b, so I want to factor out that negative inside the sign. So 10 pi over 13x minus 3 pi over 26. And we know that because sine's odd, sine of negative an angle is going to be negative sine of the positive version of that angle. So 10 pi over 13x minus 3 pi over 26 plus 3. Okay, so that is problem 6. And now I just want to talk about the problem that was talking about inverse cosine of cosine x. So that was on the review. So if we think about y equals inverse cosine of cosine x. So remember what domain means. Domain means what we can put in for x. Well, the domain of cosine itself is anything. So I can put anything, any angle in for x. So the domain is all reals. Again, there's no restriction on what I can put in for x. However, when I think about what's coming out of cosine of x, well, that'll be anything that ranges from -1 to 1. And so I know the inverse cosine of all ratios from -1 to 1, well, the range of that will be the range of inverse cosine, which is 0 to pi. So again, the inputs, which are angles, all those x angles can be anything, but the output, because cosine x is from -1 to 1 and inverse cosine is a 1-to-1 function, so we restricted the domain, is just 0 to pi. So then when I go about, so let's think about what we have. Along the x-axis is angles. So let's think pi over 2, pi, 3 pi over 2, 2 pi, and the same in the negative direction. And it goes on forever, right? So negative 3 pi over 2, negative pi over 2. But in the y, all I'm getting is 0 pi over 2 pi. So when I do inverse cosine of cosine 0, well, cosine of 0 is 1, and inverse cosine of 1 is 0. So I'm back here. If I put in pi over 2, cosine of pi over 2 is 0. Inverse cosine of 0 is pi over 2. So notice it's like completely undoing each other. So it's becoming y equals x so far. But then, so when I put in pi, cosine of pi is -1. Inverse cosine of -1 is pi. So right there, it's looking at a straight line. But then when I do 3 pi over 2, well, cosine of 3 pi over 2, we're back at 0. And inverse cosine of 0 is pi over 2. And when I put in 2 pi, cosine of 2 pi is the same as cosine of 0, which is 1, and inverse cosine of 1 is back to 0. So you're going to get this, still this oscillating effect. Of course, it's oscillating between the angle of 0 and pi, but it's going to be straight lines because of that undoing effect of a function composed with its inverse. And it'll be the same going in this negative direction too. So plot a few points to get the feel of that. And hopefully that's helpful.